do a quick video for intro to the geometry of circles. We talked about different elements of circles. One is that they have an infinite number of sides, an infinite number of vertices, but you could also say they don't have any vertices and they don't have any edges, so it's kind of a conundrum. But the idea of a circle is really based on the idea that there's two parts to a circle. There's a center we call HK, and then there's a equidistant radius to where all the points are on that circle. Because they're all the same distance away, we're going to assign that with the distance r and pick a point we call x comma y. If we have a center HK and a point xy, always the same distance r, all you do is the distance formula, x minus h squared plus y minus k squared equal to that radius squared. So the equation of a circle isn't really something to memorize, it's simply the distance formula. Okay, so if you have a center, 2, x minus 2 squared, and y is negative 3, y minus a negative 3, and a radius of square root of 7 squared, you'll have the equation of the circle. That's all you have to do to find the equation of the circle. There's a general form that, and I think it's kind of cool the way they did it. They took the x minus 2 squared plus y plus 3 squared, expanded it out, and then regrouped the x squared and the y squared, the x, which was negative 4x, and the y, which was 6y, and then they put the 4 and the 9, which is 13, minus 7, which is 6, equal to 0, into this nice little format. So you get x squared plus y squared minus 4x. They put the minus 4 as in something they called d times x, and then the 6 they called e times y, and then the 6 they just called f as a constant. And so this is the general form for a circle. D, E, and F, I don't know why they didn't do A, B, and C. There's probably a good reason for it, but that's your general form. And the reason that there aren't any coefficients for x squared and y squared is because, oh, I know why they didn't do A, B, and C, is for parabolas and hyperbolas and ellipses, you will have some coefficients A and B, and some, not C. And so that's why they left them off. D, E, and F will be constant for those. And then just real quick, if you're doing any completing the squared, x squared plus 6x, I like to leave a hole here, and then do y squared minus 2y, leave a hole here, move the 6 over to the other side. Then what you're going to do is take the middle term and do what we call half and square. Half and square will be 3 squared is 9. So you add 9 here. You got to add 9 to the other side. Do the same thing here. Half and squared. Negative 2 over 2 squared is going to be plus 1. Don't forget to add 1 to the other side. So this will just be x plus 3, because the square root of 9 is 3, and the middle term is positive, plus 3 squared. Y minus 1, because the middle term is negative, squared will be equal to 15 plus 1 is 16. This is my equation. The center is negative 3, 1, and the radius is the square root of 16, which is 4. So that's how you take a general form and turn it into a form for finding center and radius, and then taking a radius and getting it into general form. We did some group problems, and then we'll look at tangents to a circle next. So part 2 here with tangents to a circle, we've got an external line. It's not touching the circle, tangent, and then the secant. Chord is inside, the secant is the line that crosses through it. When we look at tangents to an external point, what did we say was true about AP and AB? What did we say about this length and this length, BP? They have to be congruent, right? Okay, so we're actually not going to deal with that. What we're going to look at is actual equations of lines to go through an external point tangent. Now, if you think about it, this is not as easy as it sounds, because if you have a point out here, x, y, and you have a center, h comma k, and you have a radius here, yeah, I get it that these are perpendicular. But how is that going to help us find that line, right? If you don't know what that tangent point is, that's going to be a little tricky, isn't it? So we're going to deal with that. So the first thing that we're going to do is, let's say we do have a point and we want to find the equation of the line. So we have a point on a circle, 8, -2. We know it's on this circle. Here's the equation for it. We want to find the equation of the line, tangent. Okay? So what process should we go through, do you think? What would be a logical process? I want to find this line. What do you know about this line and this radius? Perpendicular. So if you knew this slope, what could you say about this slope? Negative reciprocal, and then you have a slope, you have a point, you can find the line, bam. Okay, so that's the process we're going to go through. So just real quick, you're going to take this x squared minus 8x plus a whole plus y squared equal to 4, move the 4 over, half n squared, this will be 16, add 16 to this side. There's nothing here, this is all good. So you have x minus 4 squared plus y squared is equal to 20. So what's the center of this one? 4, 0, like it says. And then the radius is the square root of 20. Now, actually, the square root of 20 isn't going to enter in at all. But the slope is, because we know this point here, so we can find the slope from C to P, which is the change in y. Don't do change in x, please. Change in y, -2 minus 0 over 8 minus 4, which is -1/2. So what's the slope of the tangent line going to be? 2 over 1. Yep. All right, so you have a point, x, y, and you have a slope. So you just go x minus 8 times the slope is equal to y minus -2. This is point slope form. Are you okay with that? I didn't go too quickly on that, did I? So you're going to have 2x minus 16 equal to y plus 2. If you put it all on the same side, you get 2. How did they write that? Yeah. 2x minus y equals 16, and 2 is 18. That's the equation of the tangent line. Fine? Easy. That one isn't too bad. You won't have trouble with that. This is the one you might have some challenges with. So watch this one carefully. It says find the equations of the tangents from an external point. So here's your external point, 0, -4, to this circle. Now they gave you the circle, and I'm not going to go through it, but this is the equation of the circle. The center is 5, 1, and the radius is the square root of 10. Okay? Now here's the tricky part. The tricky part is we want to find the equation of these lines, and we don't know what this tangent point is. Tan point is gone. So what we're going to do is we're going to make an equation of this line using slope m. Okay? So we're going to have x minus 0, because we know it goes through point 0, negative 4, times slope m is equal to y minus negative 4. We know that mx minus y is going to be equal to 4. No, I don't want to do that. I want to put it all on the same side. Minus y minus 4 equals 0. This is the line. Okay? We doing okay? Is that part all right? That's this line. Mx minus y minus 4 equals 0. Doing all right? Write that down. Because this is really the only tricky part to the problem. What's the distance from the point to the line? Square root of 10. So the square root of 10 is equal to the magnitude of mx minus, I got to erase this part, y minus 4 over the square root of m squared plus negative 1 squared. Where in the world did that come from? Did I just make that up? I did not. Distance is absolute value of ax plus by plus c all over square root of a squared plus b squared. We derived that yesterday. Distance from a point to a line. But I need a point in here. Do we have a point? Do we have a point that this line is going to that has a distance of square root of 10? What is it? Is it negative 4 or 0, negative 4? No, it's what? Center of the circle, 5, 1. This is out of the box. Nobody's doing this in any math class anywhere in the high school. This is different stuff.
So the m times 5, so x is 5 then?
Yes, in this, for this distance. See, what we're essentially doing is we don't know this point, this tangent point, like we did in the last problem, but we do know that this general equation for the line distance is root of 10 to 0.51. We do know that. So since we knew that, we can take this general equation for line and put the 0.51 in for x1 and y1. And then we can figure out, this was like x1, y1. So then, we're not done yet, but that's where it came from.
B is negative 1 and A is
Yes. ax1 plus by1 plus c over a squared plus b squared square root. So the square root of 10 is equal to 5m minus 5 over the square root of m squared plus 1. Now we have two situations. One is, if we cross multiply here, you're going to get square root of 10 times the square root of m squared plus 1 equal to absolute value of 5m minus 5. Then when I square, I guess this is only going to be one answer because we're going to square it both sides. 10m squared plus 1 is equal to 25m minus 20m squared plus 20m plus 25. And so let's see, this is 10m squared. So 25m squared minus 10m squared is 15m squared. Minus 20m, 25 minus 10 is just going to be plus 15 equals 0. Divide everything by 5 and you're going to get 3m squared minus 4m plus 3. And right? This is 10m m squared plus 10. What's that? Oh, thank you. You found it. I made a mistake right here, right? What should that be? Thank you. Appreciate it. 50. So then if you divide by 5, you get 10. No. Okay. I feel like I'm doing something wrong here. 25m squared minus, this is minus 50. Oh, okay. And then I'm going to, with that 50m, now I'm going to still have 50m. And then I'm going to divide by 3. Okay, everything good? Okay, let's just. So this is 50. Then we're going to subtract 10m squared, so it gives you 15m squared minus 50m. And then this is just going to be 25 minus 10 is 15. Now we're going to divide everything by 5 and get 3m squared minus 10m. There we go. Plus 3. And so you're going to get 3m minus 1, 3m minus 3, and this is going to be a, oh, well, this is not a 3 anymore. So this is going to be plus 1, right? They're both negative. So then you're going to get m is equal to 1/3 and m is equal to 3. Whew. Now, that is what you'll put into this equation. So this one is just going to be 1/3 x minus y minus 4 equals 0. And what was the other one? 1/3 and 3? 3x minus y minus 4 equals 0. Those are the two equations. And you can solve for y pretty easily for that. So a little twist there. The twist is you got to get a general equation first for the line. Then you use the distance formula to figure that out.